Welcome to the first section of this course in which I will introduce you to cloud and cloud computing. So this section is not going to be hands-on, it's just some theory and some slides, but hopefully it will put some context into why the cloud is useful and how it works. So let's go back to the very basics. How do websites work? Well, we have a server hosted somewhere, and we as a web browser want to get access to that server to visualize a website. What we're going to do as a client is use a network between ourselves and the server. And the client will find the network and will use the network to route the packets, the data, into the server. Then the server will reply to us and we will get the response and we can view a website. Obviously that is very simplified, but that gives you an idea. Now for the clients to find the server and the server to find the client, you need to have IP addresses. So a client have IP addresses and a server also have an IP address. And so the idea is that when you use an IP address, you can send a request to wherever you want, to the server you want, and the server can know how to find you back. This is very similar to when you are writing some letters to your friends. For example, you would write a letter and that would be your data and you would be the client. Then when you send the letter, you put it in your mailbox, and then the network will be the network of the post office. Then the post office will use network and the address you put on the letter to route your letter to the destination, which is in this case, the server. And then if your correspondent wants to reply you back, they can use the address you put on the back of the envelope to write you back, and again, use the same network to get the letter back to you. So servers are just like the network of your mail. Hopefully that's a good analogy. So what is in a server? Well, a server is going to contain a CPU, and a CPU is a little piece that will be doing some computations. It will be very helpful to do some calculations and find results. And then your server also needs RAM or memory. This is going to be very, very fast memory, which will allow us to store information and retrieve it very quickly. So when we have a CPU and a memory bar, what do we get? Well, we get a brain. Think of your brain, right? When you are thinking, you are actually making computations. Very complicated ones, but they are computations. But then you need to retain some information, and again, we have memories, and these memories are in our brain. So if we think of the CPU and the RAM together, they sort of look like a brain. Now we also need to have some more long-term storage of data. Obviously, it's still not brain as humans, but in computers, we have included some special storage to store data, for example, files. And then, if we want to store the data in a more structured way, we're going to use a database. And a database is going to be data formatted in a way that we can easily search it and query it. Finally, in the server, we're also going to have some networking aspect, okay? So it's going to be routers, switch, DNS servers, and don't worry, all these terms we'll be seeing them later on in this course. So in a server, we have an aspect of compute, memory, storage, maybe our server sometimes is a database, and we have a networking aspect. All these things are going to be super important going forward because the cloud is going to be giving these things for us on demand. So if we just want to define a little bit of IT terminology before we get started, the network is a bunch of cables, routers, and servers that are going to be connected with each other. And the router is a specific device that will forward the data packets between computer in the networks, and they will know where to send your packets on the internet, just like your post delivery service. Now when we have a packet and it arrives at the destination, there's a switch, and the switch will send the packet to the correct client on your network. So if we put all these things together, it looks like this. Our client will send the data to a router, the router will find its way all the way to a switch, and the switch will know to which computer in your network to send the data to. So why do I introduce all these things? Well, let's go back to traditional IT. When people used to start websites or companies before, they used to do it in their home or their garage. And so they would literally go to the store, buy a server, and they put the server in their home. You may have seen TV shows, you may have read some documentation on the internet that describes, for example, how Google was made. You know, Google was started in a garage. Now, as your website grows, you need to add more and more servers to serve that demand, and so your home starts to be filled with servers. So this is bad, right? But your company is getting bigger, you're generating some money, so you're going to move to your own office and you decide to allocate a special room, which is going to be called a data center. In a data center, you're going to have, again, your servers, and you're going to be able to scale them by adding and purchasing more and more servers. Now this worked, and this worked for so many years, but there are a few problems with this approach. Number one is that when you have a data center or your own home, you're going to have to pay a rent. Then you're going to have to add power supply, cooling, and maintenance, because it does require some electricity to run your servers. It does require some cooling because the servers do get hot, and sometimes they break down, so you need someone to do the maintenance. On top of it, if you want to add or replace servers, it will take a lot of time because you have to order them, and then you have to hook them up in your center. Scaling is limited. If tomorrow you're getting 10 times bigger, you're going to need 10 times more servers, but you may not have the time or the space to do so. You also need to hire a team that is going to be there all the time, 24/7, to monitor the infrastructure in case something goes wrong. And what if there is a disaster? What if there's an earthquake? What if there's a power shutdown or even a fire? That would be bad, right? So can we externalize all this? And the answer is yes. And that will be the cloud. So I will see you in the next lecture to discuss a little bit more about the cloud. So now let's talk about cloud computing. So what is cloud computing? The definition is as such. Cloud computing is the on-demand delivery of compute power, database storage, application, and other IT resources. The very important keyword here is on demand. You get it when you need it. And then through a cloud service platform, you're going to get a pay-as-you-go pricing. That means that you're only going to pay for what you requested when you requested it and as you're using it. When you're done using it, you're not going to pay anymore. This is a big shift, right? Then, this is cloud computing. So we can provision exactly the right type and size of computing resources you need. Do you need a big server? We have that for you. Do you want a small one? We have that too. Do you want 10? Yes. Do you want 2 tomorrow? Of course. The cloud really allows you to adapt to the type and size you need. Then you can access all these resources, not with 24-hour notice, not with 2 hours notice, but instantly. You don't need to order things in advance. When you want a server, and you'll see this in this course, you'll have it within seconds. Then the cloud will also give you a really nice interface, so you can easily access your servers, your storage, databases, and a set of application services. Something about the cloud, but in specific, AWS, which is Amazon Web Services, owns and maintains the network-connected hardware required for these application services, while you provision and use what you need via a web application. So we'll see with this interface, we'll make all these things a reality. Now, let's go back to our traditional IT. So we're changing. We have our office or our garage, but now instead of building our own data center, we're going to use the cloud. And in the cloud, which is also a data center, it's just not our data center, we're going to have servers, 1, 2, 3, as we need and as we go. And we're just going to pay for exactly what we're using. So you have actually been using the cloud without even knowing it, because it is omnipresent, but not necessarily visible. So if you use a web client such as Gmail, well, for example, it's an email cloud service, and you're going to pay only for the emails you're stored. You're not provisioning servers when you use Gmail, you just use it. Maybe you've stored some data on the cloud, maybe through Dropbox, Google Drive, Google Photos, iCloud, I don't know. But with Dropbox, for example, it's a cloud storage service. You're going to put your files on Dropbox. And originally, fun fact, Dropbox was built on AWS. So we've been using a cloud storage service as well without knowing it. And Netflix, it's huge. It is built entirely on AWS, and it provides you a cloud service, which is to get video on demand. Now, obviously, these cloud services are very different from AWS, but we'll learn what it goes behind these services and how AWS can help you build these kind of cloud services. So let's go one step further. There are different kinds of clouds out there. The first one is called a private cloud, and a provider could be Rackspace. This is cloud services used by a single organization. They're not exposed to the public. So you get your own private cloud, your own private data center. It's just managed by someone else. You still have complete control over it, and you have more security for sensitive applications, which may meet some specific business needs. This is out of scope for this course, but still good to mention. Now the public cloud is more interesting. So 3 famous cloud providers that are public are Microsoft Azure, Google Cloud, and Amazon Web Services that we'll be learning in this course, obviously. So in this case, the cloud resources owned and operated by a third-party cloud service provider, and they're delivered over the internet. And we'll see the 6 advantages of using cloud computing. So in this instance, that means that from AWS, we'll be able to request what we need when we want it. And then lastly, which is also important for the exam, is the concept of a hybrid cloud. So with hybrid, we're actually going to do a mix of private and public. We're going to keep some servers on premises, and we'll extend some of the capabilities we need into the cloud. That means that we'll have a hybrid of our own infrastructure and the AWS cloud. We'll have control over sensitive assets in your private infrastructure, but we'll have the flexibility and the cost effectiveness of using the public cloud. Now, 5 characteristics of cloud computing. The first one is that it's fully on demand and self-service. Users, and we'll see this in this course, we will be able to provision resources and use them without having anyone from AWS intervene. Then we'll be having access to a broad network. The resources will be available over the network, and they can be accessed in diverse ways, as we'll see in this course. It'll be multi-tenancy, and we'll have resource pooling. So that means that not just us, but other customers from AWS can share the same infrastructure and applications while still having security and privacy. And then these multiple customers are going serviced from the same physical resources. So here, me, you, and other customers, we're going to share this entire data center of the cloud. This gives us rapid elasticity and scalability. That means that we can automatically and quickly acquire and dispose resources when we need. And that means that we can quickly and easily scale based on demand. And that is a major advantage of the cloud. Finally, it's a measured service. The usage is going to be measured, and we're going to pay exactly for what we have used. This is a big shift from on-premises. Now, 6 advantages. We are going to trade capital expenses for operational expenses, so CapEx for OpEx. That means that you don't own hardware, you're going to pay on demand, and that will reduce your total cost of ownership, your TCO, and your operational expense. That means that you don't buy the hardware in advance, you're just going to rent it from AWS. Then we're going to benefit from massive economies of scale. The price is because we are using AWS, not just us, but other customers, and so many people are using it, then the prices will be reduced by AWS over time because AWS will be more efficient at running due to its large scale. We also need to stop guessing capacity. Before, we had to plan and buy servers in advance and hope that it would meet the capacity, but now we can actually scale automatically based on the actual measured usage for our application. And because everything is on demand, we have increased speed and agility. We can create, operate, and do stuff right away. No blockers for us to be efficient. And finally, we have a huge cost that we don't need to have anymore, which is we can stop spending money running and maintaining data centers. And this allows a team of, say, 5 people to create a global application in minutes, thanks to leveraging this AWS global infrastructure that is going to be worldwide. Okay, so the problems we just solved by using the cloud is that we're more flexible, we're more cost effective, we are more scalable because we can add resources as we need to go along. We're elastic, we can scale out and scale in when needed. We also have high availability and fault tolerance because we don't rely on one data center, we rely on a fleet of data centers all around the world. We're more agile, we can rapidly develop, test, and launch software applications. And all of this make the cloud a really no-brainer. So that's it just for an introduction of how the cloud is going to be effective. Now in the next lecture, we're going to view one step further what are the different types of cloud computing. As we will see in this course, there are different types of cloud computing, and it is important for us to be able to recognize them. The first one is called Infrastructure as a Service, or IaaS. This is to provide the building blocks for cloud IT. With this IaaS, we're going to provide networking, computers, and data storage space in its raw form. And using these building blocks, these building Legos, we're going to be given a very high level of flexibility, and we can easily understand how we can migrate from traditional on-premises IT to the cloud. That is the first service we'll see in this course, which is going to be EC2. Then we're going to get platform as a service. In this, we're going to remove the need for your organization to manage the underlying infrastructure, and you can just focus on the deployment and management of your applications. And then one step even further is software as a service, or SaaS. This is a completed product that is going to be run and managed by the service provider. So if you want to compare all these things, well, let's take an example. On premises, you're going to manage everything. So your applications, your data, your runtime, your middleware, the operating system, virtualization, servers, storage, and networking. And that's a lot. With IaaS, so infrastructure as a service, we're going to manage the application, the data, the runtime, the middleware, and the OS, but all the virtualization, servers, storage, and networking are going to be managed by others, and in our case, AWS. With platform as a service, we manage even less. So everything from the runtime to the networking is managed by AWS, and the only thing we care about when we use a platform as a service is our application and our data. And finally, well, if you're using software as a service, everything is going to be managed by AWS. So how does it translate? Well, with IaaS, we can use Amazon EC2 on AWS, but we have other services such as Google Cloud, Azure, Rackspace, DigitalOcean, and Linode, which will provide us a cloud computing infrastructure as a service. Platform as a service also exists on AWS with Elastic Beanstalk, and we'll see all these services obviously in this course. And outside of AWS, we have Heroku, Google App Engine, and Windows Azure. For software as a service, we'll also have this on AWS that represents many services of AWS, for example, Rekognition, when we want to do some machine learning. But we've been using it as well in the real world with Google Apps such as Gmail or Dropbox or Zoom for your meetings. So the clouds have different flavors, but one thing is common is that the pricing is very different from what you know. AWS has 3 pricing fundamentals, and it will follow the pay-as-you-go pricing model. So for the compute, and that represents various services, we're going to pay for the exact compute time. For the storage, we're going to pay for the exact amount of data stored in the cloud. And for the networking, we're going to only pay when the data leaves the cloud. Any data that goes into the cloud is free. And this solves the expensive issue of traditional IT, because now we only pay exactly what we need, and so we have huge cost savings ahead of us. So that's it for this lecture. In the next lecture, we'll be having a deeper dive on AWS. Now let's look at the history of the AWS cloud. So it was launched in 2002 internally at Amazon.com because they realized that their IT department could be externalized. So their Amazon infrastructure was one of their core strengths, and they said, you know what, maybe we can do IT for someone else, for other people. So they launched their first offering publicly, which was SQS in 2004. In 2006, they expanded their offering and they relaunched with the availability of SQS, S3, and EC2. Don't worry, we'll see all these services in this course. Then they expanded and they said, you know what, we don't have to be just in America, we could be in Europe. And then fast forward to today, we have so many applications that used to run or are still running on AWS, such as Dropbox, Netflix, Airbnb, or even the NASA. Now, let's look at where AWS is today. If we look at the Gartner Magic Quadrant, which sort of ranks the cloud providers, as we can see, AWS is on the top right corner, which is a leader. It's able to execute really well, and it has a really great completeness of vision. It is followed closely by Microsoft and Google, but still, in 2019, AWS had $35 billion in annual revenue, which is huge, and accounted for 47% of the market in 2019, with Microsoft being second with 22%. So by learning AWS, you are learning a tool that is widely used. It is a pioneer and leader of the AWS cloud market for the 9th consecutive year, and it has over 1 million active users. So what can you build on AWS? Well, pretty much everything. AWS will enable you to build sophisticated and scalable applications, and they are applicable to a diverse set of industries. Every company has a use case for the cloud. So Netflix, McDonald's, 21st Century Fox, Activision, they're all using the cloud. And use cases can include just transferring your enterprise IT, or using the cloud as a backup and storage, or doing some big data analytics. You can also host a website, or create a backend for your mobile and your social applications. Or you can have your entire gaming servers running on the cloud. The applications are endless. Now, AWS is global, and this is where we are going to learn a bit more specifics about how it works. So we have AWS regions, we have availability zones, data centers, edge locations, and points of presence. And all of these can be represented on the map right here. So let's go on this website to have a quick look at it. So this is a cool map because on this website, we can see how AWS is global. So if I click on it, I can, scroll the world and see what is happening. So we can see that AWS has multiple regions, and they're in orange, and they're all around the world. For example, Paris, in Spain, in Ohio, in Sao Paulo, Cape Town, Mumbai, and everywhere else. So AWS truly is a global service. On top of it, each region are going to be connected through the network. So these are the network reconnecting the regions, and this is a private network of AWS. And then within each region, for example, if I really scroll into the Cape Town region, we can see that we have blue dots, and each blue dots will be availability zones that we'll be describing in the next slide. So as we can see, what I want to get you out of this is that AWS truly is global, and we can leverage the infrastructure of a cloud provider to make ourselves, our application, global. The first important concept in AWS are regions. So regions are all around the world, and we saw it on the map from before. The regions have a name. It could be US East 1, EU West 3, and we can see the mapping of the name of the region to their code on the console that we'll see in a minute. Now, a region, what is in it truly? Well, it's going to be a cluster of data centers, so many different data centers located near, for example, Ohio or Singapore or Sydney or Tokyo. When we use AWS services, most services are going to be linked and scoped to a specific region. That means that if we use a service in one region and we try to use it in another region, it will be like a new time of using the service. Now, a question that may come up in the exam is, how do you choose an AWS region? So say you're launching a new application, where should you do it? Should you do it in America, in Europe, in South America, or in Australia? Well, the answer is, of course, it depends. But let's look at some factors that may impact your choice of an AWS region. The first one is compliance. So sometimes governments want the data to be local to the country you're deploying the application in. For example, data in France may have to stay in France, and therefore you should launch your application in the French region. Then there is also a concept of latency. So if most of your users are going to be in America, it makes a lot of sense to deploy your application in America close to your users because they will have a reduced latency. If you deploy your application in Australia and your users are in America, they will have a lot of lag using your application. Then also, not all regions have all services. Okay, some regions do not have services, and so obviously if you're leveraging a service with your application, you need to make sure that the region you're deploying into is available and does have that service. And finally, pricing. So pricing does vary from region to region, and you need to consult the services pricing pages to see what the differences are between the regions, but this could be obviously a factor that could impact your deployment of an application into a specific region. Now, availability zones are what actually are going into the region. So each region will have many availability zones, usually 3. The minimum is 3 and the max is 6, but really the usual is 3. So let's take the Sydney region as an example. The Sydney region code is AP Southeast 2. So we're going to have 3 availability zones in Sydney: AP Southeast 2A, AP Southeast 2B, and AP Southeast 2C. Now, each of these availability zones are going to be one or more discrete data centers that will have redundant power, networking, and connectivity. That means that in Southeast 2A, I can have 2 data centers, maybe as well 2 in 2B and 2 in 2C. But it could be 1, it could be 3, it could be 4. We don't really know. AWS doesn't tell us that. But what we know is that these availability zones are separate from each other so that they will be isolated from disasters. So if something happens to AP Southeast 2A, we know that it is designed not to cascade into AP Southeast 2B or AP Southeast 2C. So they're really isolated from disasters. And then these data centers, these availability zones, they are connected with a high bandwidth, ultra low latency networking, and therefore all together being linked together, it will form a region. Okay, next, the only thing we need to know about AWS for the global infrastructure is the points of presence or edge locations. We will see them in details in the global section of this course, but you should know that AWS has more than 400 points of presence in 90 cities across 40 countries. And this will be very helpful when we deliver content to the end users with the lowest latency possible. And this is what you see on this map. Now, again, I'm going quickly over this because we'll see this at about the middle of this course. So now, how about we just play around and do a tour of the console? We'll see that AWS has global services such as IAM, Route 53, CloudFront, and WAF, but we'll see that also most AWS services are going to be region scoped, such as Amazon EC2, Elastic Beanstalk, Lambda, and Recognition. Finally, to know if a service is available in your region, there is a region table you should check out right here. So welcome to the AWS console home, and in this page you can do a lot of things. So first of all, let's have a look at the top right corner of the screen. Right now, this is what's called the region selector, and right now I am in Northern Virginia, US East 1. But it is advised for this course to choose a region that is geographically close to you. So because I'm in Europe, I'm actually close to Ireland, so I can choose EU West 1. But if you're in other regions of the world, for example, if you're in Africa and you're close to Cape Town, then choose this. Of course, you don't have to physically be in that region to use that region, okay? You can, for example, choose whatever region makes sense for you. So choose whatever is closest, and this will give you the lowest amount of latency. Next in the console, you will see a list of recently visited services, and it should be empty for you, and I just tried that one, so it's showing one right here for me. On the bottom, you get some information about AWS. You get the health issues, if need be, and cost and usage info for your account, as well as tutorials to build a solution, and so on. So this web page is actually changing a lot over time and has changed a lot for the past 2 years. And so it may not look exactly the same as you. And in case it looks very, very, very different, I will re-record this lecture. Okay, so once we have this, we need to look at services of AWS. And for this, 2 options. The first one is to go on the top left, click on services, and you can either look at services by alphabetical order. As you can see, there are a lot of services on AWS, or by category. For example, for compute, you would have all these services and so on. But don't worry, over time, we will learn these services and we don't have to navigate through that page. Another thing I really like is the search bar. So you can actually type a service, for example, Route 53, and then it gives you search results. So it gives you 4 services that match this query, okay? And then within these services, we can also have a look at features, and 13 features match them. So we can directly jump into the domain names of the Route 53 service. And that's a good thing. We can also look at blogs, knowledge articles, documentations, and so on. So this is quite cool. Let's go into Route 53 now to have a look at this console. So this one is very special because on the top right-hand side, it says global. That means that this console does not require a region selection, and that is more the exception than the rule. But some services in AWS are what's called global services, and no matter where you are, you're going to get the same view. But if you switch services and you go, for example, to the EC2 service, this time on the top right-hand side, as you can see, it says Ireland because I chose the Ireland region. And so based if I run this console in Ireland or say in another region, for example, in Canada, well, my view is going to be different in terms of the resources that I will see. So that's why it's important for you to remain within the same region for the entire duration of this tutorial and this course. The other thing you can look at is called the AWS Global Infrastructure that you can find on Google. And this gives you a lot of information around your services. And one thing that is very important to look at is the AWS Regional Services. And it gives you the services list by region. And so this is the table. And so, for example, if in the course I talk about a service and do a hands-on, but it doesn't seem to be in your region, you can check here and find the availability of services. So for example, we can have a look for Cape Town and see the services that are available in this region. And if you don't see a service, maybe you need to switch a region in, of course, the console to have access to it, because not all the services from AWS are in every region. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Hi. So I just want to talk to you about the UI changes that you may see between my videos and AWS. So just to explain things to you, AWS is doing a huge transition of their interface to a new guidelines for design. And so in that regards, sometimes the UI will look new, and this is what I call a new type of UI, and it looks like pretty square and so on. But sometimes you will have the old kind of UIs, which looks like this. And so AWS is doing a transition for all their services of all their UIs, and it's not all at the same time. It happens over 1 year or 2 years, and it's still happening today. So my goal is obviously to have videos as updated as possible, but it is for me, it's literally impossible to keep up with all the changes until they're done with them. So what I'm doing is that I try my best to keep my videos up to date if they are breaking changes. But if I believe that the changes are minor enough that you can find your way around the console, I will not update the video just yet. But trust me, I do listen to feedback, and whenever a video is outdated, I will go ahead and update it, okay? Another thing you can do is that if you really are lost, you can switch a toggle in most of the services that have a new experience and switch back to the old UI. If you do switch back to the old UI, like here, as you can see, you will see the old UI sometimes like you see in my videos. But really, I just wanted to give you a little warning, just to explain to you, the course is not outdated. It is my passion and my duty to make sure that you pass your exam and learn a lot in this course. And so trust me, I am monitoring every single day for updates and changes that are breaking my course. And if they do break my course, I promise that I will update my videos. But please, please, please forgive me in advance if the videos doesn't look as updated as the UI in AWS. It is very difficult right now to keep up with our changes. So thank you so much, and I wish you a very happy learning. Now, one last touch before we get started with this course. I will be referring to the shared responsibility model quite a lot, and you will see this diagram at the end of this course. This is what defines what is your responsibility versus AWS when using the cloud, and there is a shared responsibility. You as a customer, you're responsible for the security in the cloud. So whatever you use in the cloud, however you configure it, is your entire responsibility. That includes security, your data, your operating system, your network and firewall configuration, etc., etc. And AWS is going to be responsible for the security of the cloud. So all the infrastructure, all the hardware or the software or their own internal security, they are responsible of. And this is why we have shared responsibility. In the Certified Cloud Practitioner exam, you will be asked some questions around finding what is your responsibility and what is the responsibility of AWS. So I just wanted to give you a quick overview of this, and in some sections I will be referring back to this diagram and this model to tell you what is your responsibility and what is the responsibility of AWS. Finally, when you use AWS, you are agreeing to their acceptable use policy, which you can find right here. And I think it's pretty obvious, but you cannot do any illegal, harmful, or offensive use or content. You cannot do any security violation. You cannot abuse a network, and you cannot do email or other types of messages abuse. All of that makes sense, but it's good to specify it. Now, I hope you're excited. We're going to get started with this course and actually get to use the cloud. So I will see you in the next section.